I've been in the curriculum business and other things with math education for quite a while. So naturally, I was kind of interested in the new stuff that's coming out and started looking into it. And the more I looked, the less I liked. There's a number of reasons for that. One of them being that I can't really get my head around what it is that they're doing. Because I think what I've found, the information available, is not very thorough and very compelling. So I thought it might be a good idea if we got a bunch of people together who also have an interest in this and see if we can make some kind of head or tails out of this. One of the things I didn't like, by the way, is, and it may be personal, is I didn't like the tone of a lot of these documents. To me, they all read like they have a sneer in them. And I don't think that's a good thing for education. So I want to just vent some of my feelings about this.
Can you say more about a sneer, the tone that you think is sneering?
Yes, well, I will be happy to if I can find it. It should be in here. I actually marked that. I hope I brought the right. No, this is the standards. Didn't I bring the right book? No, I think I brought the wrong. Do we have the white book, the other white book? I must have left that in the car. When I get to it, I'll give you, even though I don't have it with me, I'll talk about that a little bit. So I'm going to try to divide this talk into several parts. And I should say that some of this that I'm going to say will be tongue-in-cheek, so don't take it all so seriously. One of the phrases that recurs periodically is the notion that we now have a mile-wide and an inch-deep curriculum. I don't know, I first ran into that phrase in a document put out by the second international study that was directed by our own Ken Travers. That's where I ran into it. It may have preceded that, I don't know. And it's been used a lot. And one of the things I should say is, one of the things that occurred to me while I was reading it is that there's not only a math set of standards, there's also a set of English standards. And so I thought to myself, if I'm going to read these documents critically and with intelligence, I should learn about how you do that. And those English standards would direct me in the way of thinking about things in a more systematic way. And so I actually read some of the English standards too, and I found them just as difficult to interpret as the math standards. Mile high and inch deep. And it seemed to me, the question that it raises in my mind is, why is that bad, mile wide and inch deep? Let me give you an example. Most of my dealings with the world are now with doctors. I have a whole bunch of doctors, and I have, in fact, two of them of interest to this discussion. One of them is a GP. She's the mile wide and inch deep type. And the other one is a heart specialist, and he's the, whatever it is, the mile deep and an inch wide. Aren't those people suited for their jobs in exactly the right way? Sometimes you want a specialist, sometimes you don't want a specialist. Why is it clear that that the preparation of students for, what is the word, career readiness in college should not be mile wide and an inch deep? I'm just asking that question. Does anybody have a thought about that? No. So I went on and I took that seriously, and I'm not going to write it on the board because my back hurts. I was thinking about mile wide and inch deep suggests to me a disk, right? It has a radius of well, a diameter of a mile and a height of an inch. So we could represent the sum total of what these people know as all the stuff that can be put into a disk like that. And then I made the observation, and I don't know what to make of this, and I'll get serious after that. You know, the volume of a cylinder is pi r squared h, right? And it's interesting for me to note that if you double the width, how much more do you get for your dollar? 4 times as much, right?
4 times?
So 4 times as much. And if you double what my students insist on calling the height,
I think twice as much.
then what happens?
Twice as much.
So actually putting your effort, from that point of view, putting your efforts,
But Peter, do you get to keep the inch?
what do you
When you
mean?
do this doubling in width, do you get to keep the inch?
Well, I don't know.
Or does it become thinner and thinner and thinner?
I don't know. It doesn't tell me that. I'm just reporting here. Anyway, and so I told the story of the 2 doctors that it's not clear as to what. And I would assume then that if you want to improve, I think that somehow implicit is that mile wide is too wide and inch deep is not deep enough. And so if you want to change that, what you've got to do is to eliminate stuff and concentrate on certain stuff more. And it seems to me that a document like this ought to give a really detailed account as to how they came to what conclusions about this. What did they think was superfluous? What did they think was important? But I didn't get that in any, I did a lot of Googling, but it didn't do me any good. So it seems like there's a lot of things said in these documents for which no rationale whatever is provided. Okay, so now this is where they get nasty, and I don't, unfortunately, brought the wrong book. Let me take one more look at this. Do we have the? No, this. What do they call those? Those pathways or
The
something?
progressions?
The progressions.
Yeah.
We have them.
I gave my copy to you.
You gave it. I know you did, and I thought I brought it this morning, but I think I brought it.
The progressions documents.
I brought the wrong one.
Yeah, I don't,
Anyway.
they're online, but,
Well, we're not going to.
yeah, I don't think we.
So they raised the question, why is negative times negative positive? And they say, traditionally what's been done is to go to the real world for what they say people call models, but they shouldn't be called models. I'll get to that in a minute. Models that illustrate that negative times negative is positive. And examples of such models are, well, they actually specifically mention the famous postman one, which is the story of the guy, the postman that brings bills and brings checks and takes away bills and takes away checks. And the guy's trying to figure out what his net worth is. So taking away a check versus bringing a bill, or taking away a bill as opposed to taking a check.
You can get people to take away bills.
I'm sorry? I didn't hear you.
Take away a bill?
I'm looking for people to take away bills.
The model that I'm most familiar with, which has worked well for me, by the way, and I think is a very, they make a snide remark about, and then they go through certain contortions. They actually say that they go through certain contortions of having the students think about negative time, as if that were a ridiculous thing to do. But the point is that the model that works for me has been what I call the Zephyr model, which is the Zephyr arrives in Annabrew, which is Urbana spelled backwards, at noon, precisely at noon every day. There's an eastbound one and a westbound one, and it goes at 60 miles an hour. So if it's 5 hours before noon and it's westbound, where is it? And if it's eastbound, where is it? So that gives you, now, the reference, I think, the time running backward, that, I just mentioned this, I think that's due to Max Biberman, who spent a lifetime trying to figure out a way of actually making time run backwards. And once had a great discovery, and that is you can do it if you're talking movies. And this guy worked at a pumping station, and he watched the pumps either fill or flow out, and he took movies, and sometimes he brought them home at night and he showed them as a treat to his wife, and sometimes he would show the movies forward, and sometimes he would show the movies backwards. And so then the question is, what do you see? Well, if the pump is actually emptying and you're showing the movie backwards, you would be seeing it forwards. I personally think that it's clever and the kids enjoy it. Some kids enjoy it, at least. Because
I can actually back you up on that.
you did that one, didn't you?
Yes, he did. Yeah.
And
No, we bought it.
You were a student of Max Beaver.
I took freshman algebra from Max Beaver a long time ago.
now what you have to, I think a very important principle is when you're making models in mathematics, and they talk a lot about models, you have to be sure that the model is not more complicated than the thing it's trying to explain. Because, as Einstein supposedly said, what did he say? Physics should be made as simple as possible, but not simpler. So those are the kinds of, and they call them, they say, these are not models, these are metaphors. I don't know what that means, to tell you the truth. I mean, I think they're clearly models. I mean, the Zephyr is a physical model of something that could actually happen in the real world, and which the mathematics that we have for the rational numbers explains, will predict the right answers. So I don't know what that's all about. And then they say something which doesn't set well with me, and that is, so they say, what is the real reason that negative times negative is positive? I didn't bring the actual text, but I copied it a little bit. They say the real reason that negative times negative is positive is because we want to extend the operations of multiplication to the rational numbers so that all the properties of multiplication are satisfied. By that he means the field postulates. Does everybody understand what I just said, or should I repeat it? That's the reason. And how does that make you feel?
It's made up.
What?
So like it's made up.
It sounds made up?
Yeah, it sounds.
Yeah, I could say that. I really like it
You really liked it?
as a teacher. And I asked the kids what would they suggest. And we don't have a situation. If you have give a suggestion and we didn't find anything good, and then we went to the mathematics to keep. I thought that it was,
Well, to the best of my
even
knowledge,
by not very bright students, it was very well accepted.
really, to the best of my knowledge, that was proposed in 18-something or other by a serious mathematician, of the first rank, by a man by the name of Felix Klein, who wrote a very famous book called Mathematics from an Elementary Point of View, in 2 volumes. Have you ever looked at that book? Any of you? Well, in the university, I don't know if it's still true, but in the Altgeld Hall Library, there is in those days, I think Klein was at the University of Erlangen, and he lectured, and he had students who took notes, but not the way we do. These were beautifully handwritten things, and some of these manuscript books exist in the library here, and you can look at them, and they're written in just this beautiful calligraphy almost. And that's irrelevant, but that's, Klein was certainly a serious mathematician, and if he says something, it should be taken seriously. But I think that he was wrong in the sense that I have a picture of the teacher saying we want to have these defined in such a way that the distributive property continues to hold. And there's this big football player in the class, and he's saying to himself, whatever you want, that's what you want. I just can't believe that most kids really resonate to the idea. I mean, the distributive law doesn't have much romantic appeal. Why should we hang our hats on that? I think that, but the stated categorically as that is not a good way of explaining why minus times minus is plus, I think is not very satisfactory. At least it wasn't to me. Okay, there's that. By the way, one of the mistakes that they make in this whole discussion is he makes the point several times. We make the choice that negative times negative will be positive, and that's certainly not philosophically unreasonable. As a matter of fact, I think my most favorite math joke is the 3 Little League umpires. And somebody comes up to them and he says to the first one, he says, how do you call balls and strikes? And the first guy who's an engineer says, I call them as they are. The second one, who's a physicist, says, I call them as I see them. And the mathematician, do you know this story? And the mathematician umpire says something that I've never forgotten. He says, and it's absolutely true, till I call them, they ain't. That's what the Common Core is trying to persuade people that that's true. And as a joke, I think it works very well. But as a teaching device, I don't think it works very well. I call them, till I call them, they ain't. Okay. Now, what else do I have here? I got some other stuff. But let me go now to something. So I thought the rubber hits the road at the point where you're testing to see what the kids have learned. That's what you usually look at. The rest of the stuff you can make up. And so I got here I discovered by accident that the New York Times about a month ago had an article about the Common Core, and it's called Test Yourself, 5 questions from an 8th grade math test. So can we put the first one in there? That's question number 1. And you'll notice, can they read that? Can you notice? Can you read that? Despite the fact that the Common Core specifically says we do not ask multiple choice questions, the ones that the New York Times published are all multiple choice. I'm not sure what that means. So that's question number one. And let's just talk about that question. Or as we would say, how does that make you feel?
I always thought that when I got a multiple choice question in school about something about a real life thing, I had no idea how it worked. Like, when I was in 8th grade, I didn't know how truck riddles worked.
How what works?
When I was in 8th grade, I had no idea how truck riddles worked. I would have read this question, and I don't know that it really would have occurred to me that $2 per mile is like how many miles I'm driving the truck. The very question seems kind of inaccessible to me from the start, or at least to my 8th grade self. I feel like they might have been able to choose a different model, or a metaphor for this.
Well, I think it'd be, these guys get paid to make questions like this. They get paid good salaries. These are not amateur that are just doing it for the fun of it. And I find it startling that you could create such bad questions.
When you're getting paid to do it?
When you get paid to do it, and that's all you're supposed to do all day. It is obvious that we'll go through them all 5 of them. There's not a single one of these questions that I think is not only not a good question, but an even viable question. And the first one is, here's a company, here's an outfit that continually talks about and ridicules the mathematics that we used to teach as not being real life. And I would like to submit, as I was going to do this at the end, but I'll do it now. What is her name?
Jenny?
Jennifer, is it?
Yeah, Jenny.
It's up on the.
Oh, it's up on the front.
Yeah.
Jennifer, Jenny, there's no 8th grader in the United States that will ever be faced with that question.
Rebecca.
Never. Because 8th graders don't get driver's licenses to drive trucks. Now you think I'm joking, but it shows a certain attitude, it seems to me. We don't really give a damn. We say these things. It's got to be practical, it's got to relate to their lives, or it's not any good. But when push comes to shove, and they actually ask to make some questions, they're really bad. Nobody in the 8th grade will ever have that question. So, does that bother you that these guys are so slovenly about their work?
And there are so many situations that they could ask about, so it's very...
So what else, is there anything mathematical we can say about this question? Does it make a difference that the New York Times chose to make it a multiple choice question? Does that alter the nature of the question?
I think making a multiple choice makes it easier for you to guess. I'm pretty sure most people can guess that 4 and 6
Not
are
only-
reasonable answers.
Not only to guess, but in fact, you can get the right answer by simply a trial and error. I mean, it's not much error. It makes it totally different. You don't have to know anything about linear functions and about graphs. Or you can
So
do this
what's wrong
by simply plugging in the numbers and seeing what you get.
But that makes it kind of live situations, that you could try different situations and see if it works or not. I like that. I don't like...
I agree, but I'm just saying that it sort of violates the fundamental rules that I thought they had laid down. I don't know why they were so opposed to multiple choice questions, but they didn't. I read it twice, that the documents say we will never use multiple choice.
The standards documents say we should never use multiple choice.
I don't know.
I think there
I
are
read it
multiple choice
somewhere in an
Yeah, there
account.
certainly are, yeah.
Was it in the
I don't know whether it's in
publication
the
by
standard.
them? We will not use multiple choice?
No, I don't believe so.
I don't know. So,
Well, I read it somewhere, so
Okay.
it's a misquote. And actually, it seems to me, there's of course the compulsory ethnic vows
Yeah,
that they can't be Jones and Smith, but somehow that will improve the learning of all this.
but familiarity with rental
Yeah.
is pretty much it.
Well, the
And
usual
rental
form of
rates
this
is
question
fine.
is one having to do with telephone plans.
Yeah,
Graders, but like graders might know more about telephone plans if their parents are mad about being testing too much.
I think that telephone plans is a much better way to go than truck rentals.
Maybe there are kids who also don't know telephones.
But that's one of the things I did want to mention in passing, and that is that they keep talking about real-life problems. And what is important, I think, is to keep in mind that what's one person's real-life problem is not another person's real-life problem. For their parents, it may be a real-life problem, but for these kids, it's anything but. So that's that. By the way, can you think of other ways to deal with the same kinds of issues, of other questions you could ask? Well, this is done as a function of what? The cost is a function of what here?
Distance travel.
About miles driven. Could you imagine another kind of plan?
Other than distance traveled, or other than using trucks to represent distance traveled?
What about?
Can you imagine another plan other than distance traveled?
Yes, can you imagine another plan other than distance travel? I'm not saying it's very popular, but can you at least imagine one?
Scoring points in a video game.
You could certainly do it by time, couldn't you? You can have it for N dollars a day. First day, $50, and after that, $10 a day. So you could have this as a function of time, and then you can either use the truck or not use it and so forth.
in fact, unlimited miles is probably the more common rental
For
situation.
trucks, I think it probably is.
The last couple trucks we rented, you got to use it for so many miles, and if you went over that, they charged you.
Right, then there's,
So any other comments about other questions you could ask, what the value of those questions might be?
now, I don't know if we have an evaluation person here, but or a test design person, but I think what they do is they come up with all kinds of these questions, and then they give them out, and they find out how many people get it wrong.
Well, that's
And
the
so this
psychologist.
yeah, so this question was a viable test question because it had the
Enough
right
people got
number.
it wrong.
Enough people
So
got
that
it wrong,
discriminated.
so
By
that
the way,
fit.
can you see the answer there? The answer is 22% of 8th graders were able to do that question.
Yeah.
My question to you is that good or bad? Does that make you worry about the future of our beloved land?
It makes me
Well,
worry
I think
less
that's
after
just
seeing
fine.
these questions.
Well, so here's another thing that I think you could ask. If you look at the $3 per mile, that's the easier one. It's straight rate. You could turn, when they give mileage estimates in the United States, they tell you 32 miles to the gallon, right? Whatever. Is that how they do it all over the world? How do they do it most of the rest of the world?
Kilometers on meters.
Well, they use kilometers, and of course they use the units that they use, but they don't ask the question quite that way.
They tell you how far you go on 1 gallon, or sorry, 1 liter.
Exactly. In Europe, the question would be, it would be, what am I trying to say? Liters per, how many liters can you go? No, how many kilometers can you,
You go in a liter of gas.
a liter of gas? How many kilometers? That has some advantages because that tells you when you're gonna run out of gas.
It's
The
the
que-
same thing. Kilometers per liter. or miles
Well,
per gallon.
if I were teaching a little thing like this, I would point out that whenever you have a rate problem, there's two ways to state it. Either X is per Y or Y is per X. And depending on what you're going to do with the answer, one of those may be more convenient and useful than the other. So are we done with, yes?
No, if you want to make it to real life kind of, the distance that you are going is this and this, which one would you take?
Oh, that's another thing.
That's,
I forgot to mention that.
What
The
what
question,
bothers you? I mean, that's a question that you have in mind.
the question actually is very odd because you don't give a damn when they do are the same. What you care about is which one is cheaper and at what point is it cheaper. So the question is an artificial one to begin with,
And it is because that's necessary to make a multiple choice,
yes. Right.
so that you would fall for the distraction.
Okay, the next question.
There you want to put up the next.
Have we got a little time here? Am I
Sure.
going too slow?
I would note that when Diane Ravitch posted this on her blog, a number of people responded saying that they admitted getting several of them wrong, including Diane Ravitch herself. And one wouldn't say that she's, you know, a failure in life. She's an eminent historian.
Now, this is a problem. Wait, we don't, oh, you have it?
That's it, I believe, yeah.
What is the value of, okay, so there's problem number 2. Mind you, let me repeat, these are not cherry-picked bad problems. These are the problems that the New York Times picked.
Yes.
So how do you feel about that?
What is that N plus 18 referring to?
What?
N plus 18 is the angle measure.
Yeah, there's an arc there that you can't see. I had the same problem. I had no idea what this problem was.
Eighth graders are supposed to do this?
You all understand that the problem becomes legible if you put an arc in there. So there it
Well,
is.
it might be they just,
Where are they?
say, in the angle below.
What is-
Supposed to look at the angle as opposed to whatever axis is right.
Yeah, right, this is the value, this number
Oh,
2
this
up
is the
there.
question up there.
Well, it doesn't tell me that I'm looking at
All right.
the angle, because I think I'm looking at
So 90
coordinate
minus
axes
2
and
angles N plus 18.
a line of slope.
Now,
Okay, you
So then those degrees things kind of draw my attention, if I could actually see them.
Right. And they're trying to get you to do that, to fall into the mistake of thinking 2n and n plus 18 are vertical angles, yeah.
the Germans have a wonderful word for this sort of thing. Weit hergeholt, far-fetched.
Why isn't it drawn to scale?
Why, would you please tell me how this sort of, how the reasoning in this problem will ever be used by a child in the next 60 years of his life?
When they
You
get
know, it's
started.
just, what they said is we need a test question that tests whether they can recognize vertical angles, whether they can solve an equation with variables on both sides of the equal sign, and whether they know that the sum of those angles is gonna be 90. And this one question.
I couldn't
all
agree with
three
you
of
more.
those things,
But
and that's the only reason they asked.
That has been time immemorial that questions like that have been created for precisely the reason that you mentioned. And those people who made those questions have been savaged by the people who made this
Well, you don't think it's
question.
the same people making them? I do.
Oh,
They're
you
the
mean,
very same people who have been.
oh, they
making
don't
the
fire
tests.
the old crew and get a new crew, huh?
Yeah, the new boss is the same as the old boss. I think that's
Yeah,
true.
It might even be the same person.
Yeah.
But can you imagine a less real-life problem than this one?
Well, they don't say that everything needs to be.
They say
real life.
everything. They make it very clear. And by the way, there's a little thing in the parenthesis which I have no idea what it means. It's not drawn to
It
scale.
says the angles aren't actually right.
Oh, you can't use
It's
the
a
tracker.
relevant
Well, I understand that,
Yeah.
but why
So
would
that's
you
not
give a
actually
problem
for your angle.
in which the picture is wrong?
Because they don't want them to measure the
Yeah.
circle.
Yeah, they don't want kids guessing that.
But I
it's-
mean, they get paid to make problems that are good problems, not to make lousy problems. And what is the poor kid supposed to think when he's told it's not drawn to scale? Does he have he or she have the vaguest notion of what that even means?
You know, and now that you mention it, I think of my 8th grade self might just infer that there's an arrow here, that these are vertical, that they're meant to be vertical angles. because there's a parenthesis telling me that this is somehow not something I should take serious, or not something I should take literally.
I mean, these are high stakes tests, so the kid he looks at this thing and says, oh my God, not done the scale. What does that mean? What am I supposed to do with this spread? Am I supposed to take it serious?
Yeah.
Insanity.
Yeah.
Okay, we move on to the third problem. Oh,
Third problem?
yeah,
Okay.
there's a third problem. I did not pick these problems.
I don't know that I'm not sure where the New York Times got them. I guess they were just released from the park.
I was gonna say.
Yeah, they were.
I think the park releases them, so I don't know that the New York Times got to look at the park and say, oh, we'll take this one, this one, and this
That's
one.
probably true.
I think the park said, here, ones we'll let go.
Right, the ones we're not going to use.
Yeah, oh, I don't, really?
Yeah, see, that's the ones. that-
So these are rejected problems?
Oh, you think these are rejected? Well, then my
That's.
tirade would be sort of meaningless, wouldn't it?
But, yeah,
Now, let's
But
look
they're
at the
represented.
third one.
yeah, they can't, right.
How do you like that problem, and what, do you have any comments on that?
As long as you know the word similar means triangles with the same angles, then I think you can solve it, but
Which for an eighth grade, I don't know, that's not.
Well,
Not for an eighth
you know, I think they're totally appropriate for a ninth grader.
grader. After you've had them.
Yeah, after you've had them, at the end of ninth grade. And if you just came fresh from a math class where you see a bunch of problems that are like these, which you probably have. You know,
But I mean,
they're not way up the mark.
you're
They're
telling
silly,
me
but they're
this
not-
is the way it's always been, but we've been told that this is the new way, and we're not gonna do that anymore.
that these are-
I think you're correct.
What?
But the ones that I looked at, I took either the fifth grade or the eighth grade sample tests online. And those questions did look very
They
Not,
did?
not necessarily better, but it was sort of several questions about one scenario on one page.
Well,
Yeah.
Isn't that what you're
Yeah,
saying?
yeah, I do.
I mean, it wasn't yesterday, but I did it, but.
I wanna get through with these, because I do wanna say one other thing before we adjourn. Here's 4 and 5.
Peter, in that last one, aren't both A and C correct?
I don't think so.
Yeah, I don't know.
Yeah.
32 and 93 add up to what?
I think they is 58.
Was that 58?
That's a 58.
Oh, I thought it was 58.
yeah, it's 32 and 58, 32 and 74, 93 and 55, 93 and 87.
Oh, I thought the top, my eyes didn't read, I thought it said 32 and 55 at the top.
Okay,
Okay,
let's move on.
okay, I'm in.
Number 4.
With or without a calculator?
I presume with.
I want to know what real life situation you'll be in where you can't go up and look up the formula for the volume of the cone.
Well, it might be on there, I mean, like, on the
Yeah,
ISAT,
they might
they give you
it
a card.
to you, yeah.
I hope so, but.
Yeah, I mean, I don't know about this particular one, but in the past, for this test.
Well, one thing is perfectly clear, that in this problem, you either know the volume or you don't know the volume. I mean,
You have a
Well,
cone
and
that's a
you have-
mile wide and
yeah.
an inch deep.
And you remember that you have to find the area of the same.
And remember that the whole goal of this program is to show people that math is not a collection of isolated facts.
Oh, yes.
I just want to remind you, that's what we're about to show kids. It's not a measure of memorizing factoids. And then they give them the scrum.
Yeah.
And by the way,
Well, they want to separate testing from the teaching. I mean, that doesn't mean that the teaching this way. Just
and by the way, do any of you know the name, what is his name, jeez? The guy, Polya. Have any of you read
Yeah.
Polya's stuff?
Sure.
And he has this method of how do you get people to understand, solve math problems, right? And what is one of the, which of the items that he has would deal with this particular problem here? One of the things you should do is when you have a hard problem, he suggests simplify, right? And what does he mean by simplify? He actually tells you what he means. He means use simple numbers, right?
Or smaller numbers.
Smaller numbers, use familiar numbers.
Fewer iterations.
So would you explain to me what is gained by making these numbers hard?
They're testing whether or not you can multiply decimal numbers.
Would they what?
They're testing whether or not you can multiply decimal numbers.
Well, that's a possibility, but that seems to be sort of irrelevant to me.
Did you get a calculator on the 8th grade?
I'm sure that was a calculator.
You don't at the elementary level, and you do at the high school, but I don't know at 8th grade. You get a calculator.
Okay, I'm gonna cut this short. So the cone problem is, as far as I can tell, is a purely memory problem, nothing to do with anything. There it is. We used to call those naked problems. And now look at the last problem. That's it, that's all I'll bore you with. What emotions does that arouse in you?
Well, just as with the car rental, it's kind of a,
What's a swimming pool
your
problem?
swimming pool is maybe remote from your,
Well, they try to trick you with the 6 inches.
right.
I think at least
That's
this
right.
one is something.
They're trying to do what?
They try to trick you with the inches and feet.
Trick you into thinking what?
That you have to notice that there are both feet and inches in the same problem.
Right.
Yes, and I want to talk about that.
They assume that the swimming pool has flat bottom. Most of us think of swimming pools that have shallow ends and deep ends. But they don't actually tell us that.
But
Well,
it
it says it's
says-
the shape of the cylinder.
They say it's a cylinder.
I think this one's better than the truck problem because it relies on physical reasoning skills instead of on some knowledge of a social construct like truck rental. Because at the very least, if you could imagine a cylinder and filling it with water, that's enough to solve the problem. You don't have to, it's a lot easier if you know how pools work, but they're asking you for the volume of the cylinder essentially, and it's a lot clearer than in the truck problem, if that's what they're asking for.
Well, that's probably true. I might add that I forgot to bring them, but if you go to the library here at the university, there are wonderful arithmetic books from 1890, 1900, turn of the century, that are infinitely harder than any of these, and which deal with silos and water tanks and all the things that agricultural people are actually interested in. And that's one of the other one that really got to me. And I don't know, I can't imagine how you do this problem. Somebody borrows $3,427 for a period of from April the 17th to May the 24th at a monthly rate of 5.5%. And this is surely without a calculator. You're supposed to,
This was like
you're supposed to,
1900,
yeah, you're supposed to calculate.
for what grade do you remember?
No, I didn't, I think it was just general arithmetic for people who want to learn arithmetic. So on this problem, I thought that my reaction to that problem was also that problem is correct in some sense, but it seems to me teaches bad taste. And what I mean by that is it seems to me for someone to measure in the same problem something is 4.5 feet and other things is 6 inches is simply in bad taste. You don't mix decimals with feet, except under very rare circumstances. And the whole thing, it doesn't, it's made up. That have features that you don't. So I want to finish, we can get rid of all this. Can you all see this little thing that had her put on the board? We were talking about why is it that negative times negative is positive, et cetera, et cetera. And here's a way that I've personally, is not digital with me, but I've taught this for years in various contexts, and I've had very good success with it. And I wonder what the Common Core would say about this. You draw this picture, can you all see it? And I only had to draw half the picture because it's already a little bit cluttered. You can see the two axes. You can see 1, 2, 3 along the x-axis, minus 1, minus 2, minus 3. And then you can see the black line, which I call and that's wrong, by the way, it should be the times 3 line. Let's get rid of that. Can we erase the negative sign on the bottom there? No, the times 3 line. That is the times 3 line, and it's the line that goes to the origin with slope of 3. So this is a machine to calculate, to do multiplication problems. And you want to know what 2 times 3 is, you go to the 2, and you go up to the times 3 line and over, and it does it 6. If you go to the minus 2, it goes minus 2, and it does it a minus 6. Okay, so that's a very simple thing, and it makes sense, right? It's the extension of a pattern. But now what about the other one? There's a minus, a times minus 3 line, which you can pretty much imagine what it looks like, right? It goes through. It has a slope of minus 3, and then you can do exactly the same procedures, and it will give you the right answer every time. And if you do the minus 3 line on the negative side, it'll give you the positive 6. So this has, in a little package, everything you've ever wanted to know about multiplying by 3 and by negative 3. And by the way, if you can extend this not only to negative numbers, but you can also extend it to things like a third. Because if you put if you take the third line is the one that goes not from 1 to 3, but it goes from 1 to a third. So it's a much shallower line. So this answers every possible question that you might have about multiplication of fractions. And it's the sort of thing that kids can play with and look at and put away and then bring out some other time and look at it again. And it's nothing in it that is hokey. I mean, and the feeling I have about this problem is it would make Descartes dance in his grave, because he would say, I was right. You can use geometry to explain algebraic things, and you can use algebra to explain geometry. So it has some real consequences. So that would be my answer to we would like to continue to believe in the distributive law, so we'll fix our mathematics so that it conforms to that, which to me is mind-bogglingly irrelevant.
You had asked earlier, what gets left out, I think before we started.
Yeah.
One of the things that I don't know what's left out, but they do deprecate things like FOIL.
Well, FOIL is...
So, I mean, in favor of distributive properties, you don't teach distributive properties. Because tricks, like FOIL, and there's another one that's a whipping boy, the butterfly method, which I have no memory of, so.
Well,
They say, get rid of all that, get rid of all of the...
But you know, they were getting rid of the butterfly method in 1940.
You are correct.
And they didn't succeed then.
But I remember FOIL.
What's the butterfly method?
Oh, I have to have Phil Darrow pick it up. It's a method for adding fractions without common denominators, and let's see.
Oh.
All right.
I actually do butterfly.
All right.
Plus 2/3, and I don't know, but you end up doing something like this.
Oh, hey, you told me
But
that.
so, when, you know how to do it?
Yeah.
Well, no, I remember that drawing. That's not how I actually ended up doing it.
Can you do it?
It's been years.
Oh, okay, yeah. I don't know, you know, what the methods are.
Oh,
but
wait.
You end up
Take three
doing
times-
some things out here that makes
3
sense.
times 1 plus 2 times 2
3 times 1 plus 2 times 2.
over 6?
Yeah,
Yeah, you just cross multiply.
is
Yeah.
cross
Yeah.
multiply.
So
Three.
3 times 1 is 3
Yeah.
on top.
And then you
On
divide
top.
that by the.
And then 2 times 2 is 4 on top. And then, sorry.
Okay,
over
I'm
the
sorry,
sides.
that's where the,
And then put both of those over 6, does that solve the problem?
Yeah.
okay. Put both of those over 6 down
Yeah,
diagonally.
so 3 6 plus 4 6 is what you get.
Okay.
That's right, because that's the butterfly method.
And that's the butterfly?
Is it? Is that the answer to that problem?
zoology.
Oh, let's see, well, 3 6 plus 4 6 is 7 6, 8, that's good.
Yes.
So that's the butterfly. And Phil Darrow then swears and says, what the heck does that have to do with mathematics?
Well, I'm gonna show you something worse. I learned this in one of the most prestigious math departments in the United States at the University of Chicago. And we learned this. You know what these guys are? You recognize those? Those are the angles that you're
Yeah.
supposed to know.
Yeah,
Yes.
well, that was common trick.
Those are the common angles.
Okay.
I think Tom has got that.
Square root of 3 over.
I think the third degree
I think
calls
they
that
gotta
a
have the roots of it.
Yeah.
Those have to have square roots on them too, don't they, Tom? 1 over root 2 is root over 2, so that's right.
No, it's a third degree this time.
Is this right?
But
This should be 1, right?
Yeah, 60, 30,
I think
Yeah.
that's
well,
And that's the right answers.
For what?
0,
Sine or cosine, I think?
1 over root 2, 30 degrees is root 2.
Peter, what are you calculating?
What?
What are those numbers supposed to represent?
This is supposed to be the
this,
the sign.
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 oh, these are
Okay.
signs.
These are
For,
signs.
for,
Why did I screw this up? This is-
yeah, that's what, right. If you try to memorize the trick, you get all,
Yeah, but the sine of 30 degrees is 1/2, right?
The last one.
Something is
over
wrong.
is 1 6.
Why did I get this? Why am I embarrassing myself?
Yeah, I was looking, yeah.
I thought it was 0.
you don't have to.
And
For what are,
That's the sign, right? Where is it cosine?
Yeah, I'll get to
But there's a pattern.
1, 2, 3, this pattern, okay.
There's a pattern. It's very simple.
Well, I bet you can Google 1 sign, 1 cosine.
So I was taught that
Yeah, so.
uh,
I mean,
Yeah,
it's not terrible.
in a trick class.
And so you do quickly.
so Katoa.
Yeah.
What's the sine of
So anyway, we need to go. I just wanted my last sentence to you is, you know, I get my hopes up. Every 4 years, I'm told, this is gonna be different. And we're gonna really do it right, and you're gonna rejoice. And it never happens. And I can't wait very much longer.
But let's make it not the last sentence, Peter. What would you really like to see? What was it, you know, if you put yourself back there in 1969 when you wrote Stretchers and Shrinkers, and you say, okay, by the year 2000, math education should look like,
Well, there's certain things I would like not to see. I would like to see math education not promise things which they know they can't keep, or which they ought to know they can't keep. You know, I remember my favorite example of that is there was a thing called Goals 2000.
yes.
And that Goals 2000 was a presidential initiative that by the year 2000, America will be first in the world in math and science. And that was announced in, I think, 1995. So in 5 years, everything was going to change. You knew that that was going to happen. We pointed out that the kids who are going to be best are already, most of them, in high school. So don't overpromise. Don't I don't know.
Do people, do you think it's the case that people who are not in the classroom have a simplified view of what, or who are not instructors have a simplified view of what happens in schools, so that they believe that through something like No Child Left Behind, through legislative action, we can compel every child to be at standards by 2014, which is what the legislation said. I mean, why would we say, why do we do that?
I don't know.
Why do we do that? And
Well, we're
it's
not
because-
saying what the standards are and then developing standards later by a whole bunch of different people who have different interests. Some of them want to sell their books. And,
Well, you know, I'm living now at the Windsor of Savoy, which is a place for old people. And I listen to what they have to say. They talk about things like the Common Core.
Yeah.
And what they say about it is I lived a very successful life and I have no idea what this stuff is all about, and therefore it's bad.
Yeah.
You know, so
they don't say things like these kids can't add.
I haven't heard that yet. Can't add. But they're very opposed to any kind of change in mathematics curriculum because they think that somehow.
Who was they? These could you say something about
How old
the
are these
day?
people?
No, not how old, but people who didn't use mathematics, or all kind of people, or scientists, or what kind
They're
of?
not mainly scientists, but no, there's a very cross-section of people there. Well, I mean, we were just talking about this earlier. One of the people I was delighted to meet was the woman who owned Billiards, the place on Green Street where they had fried fish
The Deluxe, which is.
the Deluxe
across
Cafe.
the street.
Exactly. And,
That one.
so she must have done some bookkeeping.
Sure. That or she just hired somebody. I think though that, you know, I mean, I know how old I am, so I have some notion as to how old you are. And I think even for people of my era, we think of math education as computation. And I think, you know, all of this stuff since the early 70s has been pushing us away from computation because you can buy a machine for $1 that used to spend 7 years of your life learning. And so there was some sort of thought, well, what else is there and why should we learn it? Because we kind of knew why we needed to learn to multiply, and now we don't. So what do we need to do? And there's a lot of different groups who have agendas and some
Right.
notion that they think what it is. And I think a great deal of what we teach, I mean, I like it, I know it, but I don't think most people need to know it. And if they want to know it, great, we'll find a way for you to learn it. But to make all of those problems compulsory for everybody to know is ridiculous.
I guess what bothers me the most about the situation is maybe selfish, but there are a lot of people making a lot of money and doing things.
Actually, only a few people make a lot of money.
I'll leave you with this last little story. Some years ago, I was teaching something about calculators, and in those days they had not just the 4-function ones, but they had the ones that also had a square root sign. And so I said, why do you think that the calculator people put the square root sign on the calculator face? And what would have been your answer to that?
This is really a pain to compute it without it.
What?
I said it's really a pain to compute it without it,
It is?
to find the square root.
Oh, but why would you ever want to find the square root?
Oh.
Well,
Most people would
here's
not.
what I said. I said, I said, I think the real reason is it costs practically nothing. So it doesn't
They have
matter
room, huh?
whether you put it on or you don't put it on. But there were several people who said exactly what you said. They said, so that you can compute square roots. And I said, why would you ever want to compute a square root? And this lady said, well, if you have a field that's, 4 by some dimensions, and you want to know what the length of a side is, then you would put the number in, and then you would calculate its
You
square
definitely
root.
would need it for the diagonal.
And I said, are you pulling my leg? You think they put that? How many people in this country do you think are busy computing the side lengths of square fields? And most people said that they didn't think there was a big market for
They
that.
don't, but they used to do it a lot in school, so people think that it's important, because school kind of
Well, I'll
told
tell you
us
why I
that it is an
think.
important thing. I don't think
I'll
that.
tell you why I think it's important, is because even in the simplest kind of statistical stuff, you want to compute square roots.
But how many people are doing statistics?
Not, but that's the only justification that I
Yeah,
can
it's-
think
I
of.
thought that just
A
school kind
standard
of told us
deviation
that
is something that
it's,
people
put
might
it
want
as
to
an
do.
important feature.
Pythagorean theorem comes pretty early in the school curriculum, and we do test it over and over again. In fact, if you look at like the 8th grade ISAT, if you know the Pythagorean theorem and how to solve a proportion, you can do the whole test. And that's kind of like the first time kids think that the calculator is something that actually can do something they
They
can't.
do Pythagorean problems.
So it's a cultural thing. I don't think that it's.
I think you're probably right, maybe Pythagorean distance form.
Yeah.
There's that one,
Finding the
Algebra.
diagonals and things.
algebra one, the name of the function, I can't remember anymore. It's like a plus b over, yeah, the root theorem, finding the roots, what's it called?
Quadratic formula.
Yeah, that, you didn't score anything for that.
If you solve
Did you
it,
ever need to know the roots of quadratic?
When it's finding the roots of a quadratic equation. People didn't know.
well, thank you.
Thank you very much, Peter.